Hi class, today we're going to be looking at light waves and the electromagnetic spectrum. So light waves do occur in different frequencies and wavelengths, and you can see that down here in this electromagnetic spectrum or portion of the electromagnetic spectrum. The frequencies will change as you go from radio waves to gamma waves, and the wavelengths will also change, so we'll show that on another slide. Light waves are represented on the electromagnetic spectrum, and it does consist of visible light, but it also has other waves that cannot be seen by the naked eye. So here's our full electromagnetic spectrum up here. We go from radio waves to gamma rays. So the key things that you need to know, you do need to know the order that they go in: radio, microwave, infrared, visible. And visible here is represented down here with our types Roy G. Biv: red, orange, yellow, green, blue, indigo, and violet. And then we have ultraviolet, X-rays, and gamma rays. The things that you need to know, as well as the order, would be what happens to the wavelength and the frequency. So in radio waves, the wavelength is long. You can see here. That would be a wavelength. If we show that there. And then low frequency. That means we have fewer waves that pass in 1 second. As we move all the way to gamma rays, we see a short wavelength. So you can see here, very short wavelength. And so it has a high frequency. A lot of waves are going to pass in 1 second. When you take a look at the visible spectrum, we have red being the first, and that's going to be a longer wavelength and a lower frequency than violet, which has a short wavelength and a high frequency. Follows the same pattern as it does on the full electromagnetic spectrum. This just shows you kind of a comparison of things along the spectrum as well. So down here, radio waves, you can see here what that would look like, and then microwave, radar, visible light here, and then X-rays, which we'd use in hospitals, and then radioactive elements have the gamma rays. So electromagnetic spectrum consists of light at all possible energies, frequencies, and wavelengths. Visible light is just a small part of the spectrum, and so we already mentioned these. The spectrum also contains X-rays, ultraviolet rays, radio waves, and gamma waves. Light actually acts in two ways. It has a dual identification, I guess you would say. It'll act as a wave, but it'll also act as a particle. So here's a couple ways that it acts as a wave. It produces interference patterns like water waves, and it'll follow law of reflection, diffraction, and refraction. Diffraction is down here in the corner. So light will diffract or bend around an object. Here in refraction, the light will bend as it moves into another medium. So it'll go, in this case, it's going fast, and then it goes slower, and it bends slightly. This would be an indication of if you were looking at fish in water and you're looking from the surface, the fish are not exactly where they appear to be due to the refraction of light. And then reflection is when we have light come in and then bounce off of that surface. Light will also act as a particle, and when it's acting as a particle, it's called a photon. So a beam of light is considered to be a stream of photons. Photons are just bundles of energy. Light waves do have a set speed, a constant number. So all electromagnetic waves in empty space travel at the same speed. And light can travel through space, which is unique. Other waves cannot travel through space. They have to have a medium to travel through. So the speed of light is 3.0 times 10 to the 8th meters per second, or if you want to put that in a different perspective, it's 186,000 miles every second. Light will change speed slightly as it goes through a different medium, for example, air to water, but we still use that constant number. It can change slightly, and sometimes a different number will be given to you if that's been calculated based on the speed that it's changed to. All right, so that is the end of the light wave notes, and we'll talk more about refraction, reflection, diffraction on another set of notes.